Okay, 2011 AIME. This is problem 3 from AIME 1. And it says in triangle ABC, AB is 125, AC is 117, and BC is 120. Let me draw that first as well as I can. So let's see. It's not quite equilateral, but it's pretty close. So I'm going to just get pretty close to equilateral. And then, let's see. So let's have this be A, B, C. And we know that AB is 125. We know that BC is 120. And AC is 117. Okay. The angle bisectors of angle A intersects BC at L. Angle bisector of A intersects BC at L. That's not good. Let me try that one more time. Okay. That's better. So that's L. The angle bisector of B intersects AC at K. Okay, so angle bisector splitting that angle in half at K on that side. Let M and N be the feet of the perpendicular. Okay, so those are the angle bisectors in blue, our triangles in green. Let M and N be the feet of the perpendiculars from C, okay, to BK and to AL. So we drop a perpendicular here, and I get the point M. Let's see, yep. I drop the perpendicular here, and I get the point N. And I want to find this length right here, MN. Okay, so, and I'll mark this as an unknown x. Here's the idea. Since this is perpendicular, if I extend this out to here, I will get an isosceles triangle here in yellow, and I know that this measure in yellow is 120. If I were to extend CN out to AB here, I'm going to draw another isosceles triangle in red, and that means that this right here is 117. Okay, and the reason these are isosceles triangles is that this blue segment from A to N is an angle bisector, and it's perpendicular down here, which means that these 2 points are equidistant, meaning that we have a perpendicular bisector, and because of that, I will have isosceles triangles here and the yellow one here. From that information, I can actually go on and say, okay, if this is 120 and the entire green side AB is 125, this is 5. If this right here, this red segment here is 117 because of the isosceles triangle again, and this entire green side is 125, I know that this is 8. And that means that this segment, this white segment right here, where the two isosceles triangles overlap, is going to be 125 minus the 5 and the 8, so minus 13, which gives me, oh, this is getting sloppy, which gives me 112. So let me say 112. And I'm going to look at this triangle, Let me redraw that. So we have this triangle. Okay. I know this side is 112. In addition to that, I know I'm looking for the length of MN. Okay. But because of the way isosceles triangles work, so you see here I have this perpendicular bisector. We talked about that, which means that those two segments are congruent. And the same holds for this side, for that yellow isosceles triangle, so these two sides are congruent, which means that this is, I think it was called the mid-segment or a mid-segment of this, meaning that x times 2 will equal this entire side, 112. Another way to say it is this length is half of 112, which means that x is 56. And the answer that I put down is 0, 5, 6.